I'm from headfi.org, and I know it's a bit strange maybe that I'm moderating a measurements panel, but one thing that some of you may not know is that we started doing, if you watch our videos on headfi, we've started doing headphone measurements, and we'll be doing other audio measurements, electronic and electroacoustic. But I'm surrounded by people who've been doing measurements a lot longer than me. Tyll Hertsens from Fidelity, I think all of you know him. He's been doing measurements. Actually, you were the first to do measurements that I can recall that were different than the ones on the sides of the boxes that we'd see in the store. They were always ruler flat, idealized measurements that I can't even doctor mine to look like that. And I remember Tyll was the first to put out measurements that were previously relegated to the labs, the R&D labs, and he did it when he was with Headroom, which I thought was a really amazing and cool thing to do. But we have a lot of panelists up here, and so I don't want to do much more talking myself because I want to get through, make sure we get through everybody here to talk about headphone measurements and essentially how they correlate to subjective impressions and sound, because there's some interesting discussions to have here with all of these gentlemen. Actually, with all of them, I think I've talked to them all about measurements. Not as much with Tyll, believe it or not, but I've read all this stuff. And so I just wanted to let everybody first introduce themselves, starting with Paul and working their way down.
Hi, I'm Paul Barton from MrSpeakers. In the last, I've been doing this for 45 years, but in the last 5 years or so, I've been focused on doing some headphones and developing good headphones, affordable headphones. And I'm here to talk about how we go about that.
I'm Dan Clark. I'm the founder of MrSpeakers. I've been doing headphones for 4.5 years and audio on and off for 25 years before that, though mostly in the high-tech and software domains.
I'm Tyll Hertsens from Fidelity, and I keep my head in a box in my house, and it does all the work.
I'm Sankar, from founder and CEO of Audeze. We started Audeze 7 years ago, and we measure and make our headphones in Orange County, California.
Hello everyone. So my name is now Tsunoda from Sony Tokyo, and as well I have been in this industry for more than 26 years now, and I'm keeping measuring the headphones for 26 years now.
All right. Well, so I wanted to start. Paul Barton is someone I've talked to a lot about audio measure. Well, actually, you know what? Let me start with Tyll first, because since you were the first to put out the lab measurements for consumer-facing use, I wanted to talk about what some of the initial reaction was. It didn't look like frequency response measurements we were used to with speakers, for example, which.
I still have a hard time interpreting measurements, and as you learn more, you realize how much less you really know about it. And I think consumers are in the same place, and I'm always pretty encouraged by the willingness for folks to take a look at something that's difficult to interpret and try. And I think what's been interesting is that there has been enough enthusiastic interest on the part of headphone hobbyists to continue to try to look at them and even build their own measurement rigs. And so it's a very hard and challenging thing, but I think the response has been really good overall to it. I think people have embraced it, even though it's very difficult to understand. And I think it has put pressure on manufacturers because the consumers are now faced with, although difficult to interpret, real information. And it allows, I think measurements provide a common ground for everybody to look at and respond to, including manufacturers. So I think it's a really important thing, and I'm very glad people are willing to pick up this meaty task of trying to understand it.
It is a meaty task. So Paul, let's talk to the manufacturers now, starting with Paul Barton, moving down the line. Paul,
Yeah.
so.
Well, with my background in loudspeakers, of course, if any of you know the history of all the work that was done by Dr. Floyd Toole at the National Research Council in Ottawa, it really centered on trying to correlate measurement with subjective evaluations. So I spent many, many years trying to understand when I measure a loudspeaker, how to interpret that measurement and predict how it would sound in a normal listening room. Well, the same thing sort of applies to headphone measurements, although the environment and the kinds of data that you get out of a headphone measurement using a coupler that emulates the ear canal or an average human ear canal, as Tyll is saying, it's somewhat difficult to interpret. But over time, if you do subjective evaluations and compare that with measurements, you acquire the skill to be able to interpret those measurements. And so that's something that I sort of hang my hat on. One of the biggest challenges with headphone measurements is that above 5 kilohertz, the couplers that have been developed were mainly developed around hearing aid development as opposed to high fidelity development. So the criteria for getting good resolution of frequency response in particular above 5 or 6 kilohertz was kind of difficult to get consistent or even to be able to interpret. So that's really the challenge. And you know, over the last 5 years, just to give you an example, some of you may have heard of a test system called KEMAR, which is a torso, which has two ears and a head, torso, and you can you know, do measurements on this. And I was fortunate that a lot of the original work that was done on KEMAR, which was originally owned by a company in Chicago called Knowles, it's now owned by a company in Denmark called Grass. It was originally developed to, and all of the data that was acquired early on with KEMAR was done by Dr. Edgar Shaw, who was actually he was the head of the acoustics division at the National Research Council, and actually Floyd Toole worked under that division. And he was doing, when I first started going to the National Research Council in 1974, Edgar Shaw was doing all the original mapping of the external ear in the pinna. And if you look through the textbooks, you can see all of this work that was being done. And I use a lot of that data that he generated back in the early days with diffuse field and trying to, and most of this work was done based on, or for hearing aid development. And so above 5 kilohertz, it wasn't really that critical. Something that I've done recently is we've been able to do scans of ear canals of 14 different human ear canals that we actually acquired from human cadavers. And we're able to make couplers of different sizes and trying to get a better transfer function and try and get better resolution up to above, and we're thinking we can probably achieve about 14 kilohertz of consistent consistent response, real response on a measurement system. So we're not there yet, and Jude and I have talked a lot about this sort of thing, and in fact, you've been talking to Grass a lot about these types of things.
Yeah,
So
they have the new canal.
Yeah, maybe you should share some of that information.
Well, yeah, we'll get to that in
Yeah,
a second, yeah, because
yeah.
that canal discussion.
Anyway, that's kind of my approach and my experience with doing headphone measurements and the challenges in doing that.
Dan, what about you? I mean, you'll send me measurements 2, 3 in the morning sometime.
Yeah, well, I think measurements serve a couple of different roles, and they're all valuable but quite different. Before I mention those, I will say one thing about the pinna. We have a couple of we also use the Gross coupler, and we did some experiments changing around the pinnas from large and small and slightly different shapes, and we also made a few of our own. And we found that the variations just based on the pinna, let alone the ear canal, and measured response were about plus or minus 4 dB above 6 kilohertz. So, you know, that one of the things that actually highlighted for me was the importance of understanding, you know, that when one person says it's bright and you don't hear it as bright, there may actually just be a physical structural difference between the ear that's coupling with the headphone quite differently, and they're hearing something different. So one of the things that raises is the specter that, well, you can't really assume that, a reproducible measurement will be perceived the same way by people, not just for the ear canal, but also the pinna. And if you go around and look at the shape and size of people's ears in the room, you will see that there's quite a bit of difference, way larger than we had in actually any of the pinnas that we were using in our experiments. But that said, what we do, we're a smaller manufacturer and we don't have a massive R&D facility. So measurement serves two specific purposes for us. The first is in the design process, where we use it to essentially validate what we're doing, make sure that we're not doing things wrong, like there aren't buried things like THD that we didn't pick up through listening, et cetera. But the process we follow is we always listen first before we measure, anytime we do an experiment or a tuning exercise, because we don't want to bias ourselves to what we're hearing or experiencing. And after we've done the listening test, then we measure it and see if that correlates with what we're listening to. And as we iterate down and we finalize the product, then what we do is we use measurements to ensure that our products are accurate and reproducible. And we actually typically build specific couplers for every single driver or headphone piece so that we can have 100% reproducibility in our measurements, and that ensures consistency in the product. So we use measurement, in a couple of different ways in the company.
All right, we'll get back to the subjective impressions, but Sankar,
Yep. So many of the points Paul and Dan already mentioned, we use measurements again for manufacturing purposes, design purposes, in production, and also to show people how these headphones sound. In the beginning days with LCD2, when we introduced it, there was a lot of questions on how does it sound and a lot of things on Head5. So measurements were a way for us to get some credibility in the industry. So every headphone we shipped in the first 4 years or something, we actually shipped a graph with it. Whether people understood it or not, it didn't matter. But people see graphs and they assume, okay, there is something behind this. That's why actually it's in sales perspective. If you see many of the headphone manufacturers, like Monster and stuff, they put so much data in the back that sometimes they don't even make sense, or sometimes there's a lot of data that people actually, when people buy it in the store, they look at it and they say, oh, there is some data here, and then they buy it. So, but it, for us, when we came to Head5, it was actually important for us to build some credibility, so we actually shipped graphs. Now we have stopped it, but people still ask us for graphs and we provide them. But one another thing that is important is our brain actually compensates for a lot for outer ear and inner ear variations as well. So what we have found out is if you tune it as what you perceive as neutral, it will be generally neutral for other people as well, because their brain, as they grow, kind of compensates for things. I'm not saying it's perfect correlation, but there is some. And the second thing that we have found out is, like what they mentioned, even above 3-4 kilohertz, there is no big correlation between what we measure and the perceived response when we go from headphone to headphone. So even if we measure it on the same rig, every a different model of the headphones, because of the way the ear pads couple and the design of the drivers, there is no big correlation. And there is correlation, but it's not easy to discern exactly from one headphone model to other. So as manufacturers, and we use it for design and evaluation, but when we present it, or in general with other manufacturers as well, we show things to people that people would, that show our headphones in good light, that fits a narrative. And we see that when people review the headphones, it's also the similar thing. So when the reviews, basically the measurements are used many times to fit a narrative that they want to put in their reviews. So I think it's as we grow and as more measurements come in, I think people will start to acquire the skill on how to interpret them, and it'll be more there'll be more things that we can discern from these measurements. Right now, when I see measurements from different review sites and even different manufacturers and different headphone rigs, there's a lot of variation that it's very hard to form an opinion. So we, like Dan said, we form a rig, we make a rig that we use a particular rig, So we are very comfortable with it, so we use it and we get the skill to make sure our headphones sound good. So.
Go ahead, Neil.
Okay. So let me talk about some about the headphone measurement at Sony, and the purpose of the measurement is that we're divided into two pieces. One is for just efficiency on the design process. Is the number one reason, because the of course we can hear everything. So and the most the final purpose of the headphones we are introduced to the market is just for listening, not for measurement. Some measurement will also make the process faster because we can look out this defect on the frequency response much easier than the listening. Of course, sometimes, for example, we can pick up the peak on the frequency response very easily, but not for the dips. Because deep, sometimes if there's a signal on the deep, you can hear it. Therefore, reduce the design process, the time for the design process, and the measurement is really a good tool for us. And the second thing is about product consistency. Because they are, as you know, the Sony is a huge manufacturer, and probably this is the biggest among us in here. And so we're also making 10,000 of the headphones daily in a day. So in this case, product consistency is really a good issue, big problem. And also measurement obviously gives us a good idea to whether the products are manufactured in a way that we intended. So that's two big purpose.
All right. Now I want to. Now that we've heard from the manufacturers, I want to talk about the subjective impressions with respect to these measurements, because we have these big variations that we see from system to system. Yours looks a little different than mine. Looks a little different from his. Well, you guys actually had an interesting exchange of information with respect to one of your articles.
Yeah.
And it gets tricky because when I use my own measurement system, and we have two different couplers we use at the HeadFi office, and you'll be seeing more from us in the later this year and into next year. But I can recognize, and I look at raw plots is what I look at for me. But then I apply. So just to be clear, when you do a frequency response measurement using a coupler with pinna, you get something that doesn't look anything like what you're used to seeing from speaker measurements. They're very different, very peaky. And when I look at them, I can interpret that raw plot to some degree. Even then, it's not perfect, not even close, because it doesn't always look like what we see on the measurement. So we apply compensation to these, and I won't go through the process of how those compensation curves are determined, but we apply compensation to essentially make them more easy to understand, more reasonable to look at. And I think most people, since you're the one who kind of put the measurements out there for most people, you've been applying, what is it? Is it a DF compensation?
It's sort of like a DF it's independent of direction, and it's a head acoustics curve.
Okay.
It's close to a DF.
And so, we're used to looking, I think a lot of us, at Tyll's measurements because he's been doing them for so long. But even then, they don't look like, you can't look at it sometimes and know exactly what to expect to hear. And in fact, I found that to be true a lot of headphone measurements. So Tyll, you've measured more headphones than maybe anybody in terms of models, various models. What are you able then to look at them and see?
So I think measurements are mostly good at telling you if there's a flaw in the headphone. For example, there are some headphones where the impulse response is extremely noisy, or the square wave responses are really kind of brutally jagged, and that usually indicates a harsh treble response usually. But there are also a lot of headphones, particularly electrostatics and planar magnetics, that always have fairly noisy impulse responses, and yet they don't really sound like it would if it was on a dynamic headphone. So I guess the answer is, for me, measurements give you a good coarse understanding of where a headphone is at, whether it's, oh, this may be a good headphone and this may be a poor headphone, but you're not going to be able to tell the difference between a good headphone and a great headphone. And what I'm beginning to see now, because I think headphones over the last 3 or 4 years have come closer and closer and closer to neutral, is that the difference between what I assume a headphone would sound like and what I actually hear when you're talking about a headphone that's pretty good is pretty large. It's hard to tell from looking at it that the Focal Utopia sounds the way it does. So in other words, as headphones are getting better and better and better, I think measurements are going to be less and less useful as a sorting tool, because once you get close, it really is surprising that you go, oh, I didn't expect it to sound like that given the way the measurement looks. So I think their measurements are helpful, but you just have to listen to it. And whoever brought up the comment of pin sizes being different and stuff like that, that's absolutely the case. And so one of the problems here is that the measurements may or may not match your ears, and the complexity of that acoustic interface is very high, and I'm not sure it's easy to interpret. So.
Oh, go ahead, Sankar.
So even before we get to measurements of frequency response and stuff, I just wanted to point out one small thing, which irritates me a lot. One thing is efficiency measurement. So when you measure efficiency in an ear headphone, you can measure it at the ear entrance point, or the ear reference point, or the drum reference point. And if you just look at the measurements presented by various manufacturers, it's all over the place. Because some headphones want to show that they are more efficient than others, so they measure it at the ear reference point, which is like if you put your hand here, the plane. Okay? So and what happens is you're maybe 2 dB or 3 dB higher in efficiency, and many times people say, this is the most efficient headphone, and we measure it and we see, this is only 98 dB per milliwatt. How did they get 103 here in their measurements? So it's the consistency of not just the measurement, the way it is presented as well, is all over the place. So the way it's presented with by different manufacturers and different reviewers is also, there's too much variations.
Right.
There's one other interesting factor that comes into play with efficiency measurements, which is what are you actually measuring, not just where. Because are you measuring power spectrum, like a noise across a broad spectrum? Are you measuring at 1 kilohertz? Yeah. Is it an A-weighted response? What is it that you're actually, there is no standard in the industry for how we measure efficiency. So people can kind of pick anything they want and use that as the metric for efficiency.
Well, they pick the sensitivity and find a measurement that gets that.
Right. I'll pick 200 hertz on this headphone and 1,000. We standardize on about 1 kilohertz. We just say 1 kilohertz is our reference point. We haven't figured out a better way to do it.
Yeah, but at least you state how you're doing it right. So actually, Tyll brought up an interesting point. You said that as the headphones get better and better, maybe the measurements become less useful. But maybe one of the questions I have and that I'm interested in exploring is maybe there are other types of measurements. Because right now, there seems to be a strong emphasis on a few different kinds of measurements, but almost overwhelmingly on frequency response. Right? Frequency response is pretty much what everybody looks at first, and sometimes only. But maybe there are other measurements that can uncover some of what we're hearing. And I'd be curious to know what you guys think about that, because I do agree. You look at the Sennheiser HD800S, the Sennheiser HD800 measurements, and I don't believe in the treble response you do see some of that difference, but the bass, purely in the frequency domain, does not show that fullness that you get with the HD800S. Now, the distortion measurement might explain some of that, right? Which you were the first to talk about.
Yeah.
Yeah, but so maybe there are other things still, right?
Oh yeah, absolutely.
To uncover some of the subjective things we hear. And so here's a question, to the extent that the manufacturers are willing to answer it, because I don't know if they're going to be willing to answer it. But are there other kinds of measurements you guys are doing? I know Sony they do a lot of high frequency measurements.
Yes. Of course, but at first, let me talk about some about this low frequency response. And basically, frequency response has a really controversial things because normally with this loudspeakers, there is some very little common understanding, which is flat frequency response and as how to say free field. And but that's headphone doesn't have such a standard on it because
Right.
because the one of the aspect that we have the idea is headphone is a room simulator in a way because so no one's listen to the music with the loudspeaker in the free field. I mean, on the quick room, and or the sometimes the diffuse sound, diffuse field. Therefore, every person has there's a favorite room. But unfortunately, these room with a good sound is the frequency response of the low frequency area is not flat at all. Yeah, every studio's owner always say, my studio is flat completely, but it's not true. But from my experience, every room has its own bass rise on below 100 hertz, and this gives you some kind of impression, the musicality. Therefore, we designed the headphone as to fit like the one model should have a studio bass response. That's what we do. Therefore, we are one of the sometimes the headphone probably you will perceive headphone is kind of audio flow, but unfortunately this is true because the headphone is a sound field simulator, and also the bass response of the headphones gives you an idea of what kind of the room are you in.
Right.
Yes.
Now, for your measurements, when you measure that, are you focusing mostly on frequency response? I mean, that's, I'm trying to see what other measurements we might do that might be more telling, because I don't think the frequency response tells the whole story.
Don't tell the whole story.
Yeah.
Never. And but in the high frequency area, there is much more the truth on the high frequency area because the probably we noticed that whereas well-reputed headphones have a good frequency response higher than 3 kilohertz because there's 3 kilohertz. There is a many argument on the how to design the high frequency area, the frequency response, because there's there is no Sennheiser guide today. There's one of the Sennheiser issued some many papers that they are targeting the diffuse field HRTF, and this does make sense, and also it's really as a coincidence. Diffuse field response of the HRTF gives us a good idea of the localization.
Right. Now, what about you, Sankar? We just had recent discussions on psychoacoustic stuff. I'm not going to say anything specific that you might, so I'll let you say what you want to say about that. But there are some interesting discussions about.
So we have been doing, a lot of measurements and also recordings to help us help us design our headphones. So we have Alexander, a Grammy-winning engineer in Santa Barbara who works at Audeze, who helps us to do recording. So what we do is now we not only take for evaluation, we record these people positioned in particular angles as reference recordings, and then we try to see if we can reproduce it for like visualization. Are these people at the same distance, what we recorded in, and these are super accurate measurements that we do. The other thing that we also have, then we do measurements for designing and this. We use everything, whatever measurements is available. We use phase measurements to see if there, especially with in-ears, as you see in a lot of balance amplitudes or phase response issues. So we think phase response is something that's actually very critical in the perception of sound stage and everything. The other things that we also noticed is if you have like for example a little resist around 800 to 2000 hertz and a little bit of peak around 6 kilohertz, it actually artificially boosts your sound stage. And we found that if you have using virtual room emulators, plugins and stuff, they use these tricks to create an artificially big sound stage.
Can you say what the tonal change was again? You said a little bit of a peak at 6K and then what?
Yeah, a little bit of peak, so a little bit researched at around 800 to 2 kilohertz.
Yeah, okay.
And then a little bit of peak around 4 to 6 kilohertz.
Yeah.
It makes your sound stage artificially big.
Right.
And then, I mean, that's not saying it's bad or anything. It's just
Right.
From a headphone design perspective, but it's not the most accurate that you can get.
Right.
So these kind of things we can easily evaluate using EQs and tools available. And also, unless you do your own recordings, it's very hard to basically find out, okay, how does this should look like. And the other thing that we have actually started playing quite a bit now is also to see how to, how do you really evaluate your headphones in a more consistent manner besides these measurements. One of the things that we are starting to do now is to see if we can actually put a room emulator and then with the head tracking unit, then maybe can you evaluate how good the sound in a particular room. So maybe in future we can create a reference room or something like that that would help you evaluate not just the frequency response or tonal balance, how is the sound stage, especially because of virtual reality. There's a lot of 3D audio R&D going on now. So how do you measure what is a good reproduction in virtual reality? How do you see whether your headphones work? Because everything is going to be headphones and VR. So now how do you actually say, is this reproducing the sound stage in VR? So what we found out was the more flatter your frequency response is, the better the HRTF filters that are in the VR headsets work. So if you have a little bit of bass boost or something, your imaging in VR suffers because of the imbalance in tonal response. So we have started working with this Israeli company called Waves to create room plugins, and some of those things that are done in game audio are amazing amount of R&D going on with, they can now do almost room emulation with ray tracing kind of things on ATI video cards. ATI just released a free library for anybody to use where you can have any complex structure be easily reproduced to emulate a room. So I think these things will actually help us as manufacturers to create better sounding headphones.
But when you say neutral, do you mean measured how? Like what's neutral? This is a big challenging question. And
So it's very difficult. So
I want to know.
yeah, I want to know too. I want to know too.
So,
Yeah.
so what we did was we have our measurements and we have a reference speaker in our that we have built, and that basically we have the room EQ'd it to flat, and and it's a little bit of bass boost, and that's basically what we use as reference. And what we did was we put these microphones on the eardrums with these probe microphones and measured individual HRTFs for each person in our engineering group. Then what we use is we use this on our DSP to see does it sound close to the speaker. So that's basically what we call neutral. So
Okay, so it's not something that we could generalize then, not very easily anyway, because it's
Yeah.
all individual.
correct, but individual HRTF is not very practical, but what we found out was you could actually approximate it, and it actually sounds very good for a lot of people. So you can basically use some cross-feed kind of algorithms where the tonal balance is not too affected, and you could basically give them some options like head size and ear-to-ear measurements, and people actually really like it in our internal tests.
Can I jump in?
Yeah.
A lot of what you're talking about is, when you think of virtual reality, I think the source material is going to be processed in such a way that it doesn't really include the room. But you got to think about this for a minute. The music that we listen to most of the time on headphones is music that was recorded to be played back on speakers in a room.
Right.
And the room has an effect on that, which is what you're talking about. And I've spent some time trying to find what that relationship is. In other words, do you make a speaker in a room sound flat? Because if you do, most people say doesn't have enough bass. Because most speakers that you put in a room are direct radiating loudspeakers. And direct radiating loudspeakers at low frequencies are omnidirectional, and as the frequency gets higher, they become more directional. So on axis, that speaker is flat, but sound power, the whole energy the speaker's putting out, is not flat. And what you hear in a room is a combination of the direct sound and the total sound power that the speaker's putting out. And when engineers and musicians mix their music, they mix it in a room that has a direct radiating loudspeaker, and they don't want to EQ it because they know that when people put a speaker in their room at home, they're not going to EQ it, and they want it to sound like it sounded in the studio. So that's why we need to put some kind of a bass boost on headphones, because there's no room there. And that's the challenge. What is that target function? And Sean Olive has talked a lot about this, and you know, come up with some kind of recommendations for the target function that needs to be achieved. And this is all based on a lot of subjective evaluations that I've experienced over my career. And just to add to that, you know, we're talking about how inconsistent the high frequency measurements can be and hard to interpret. But if you look at the papers that were published based on the subjective versus objective evaluations that were done at the National Research Council between 1974 and 1985, you will find that listeners found that the best speakers had to be very tight response, up to 1 kilohertz. Above 1 kilohertz, you could get away with a lot more than you can below 1 kilohertz. So the key is, if you don't get it right up to 1 kilohertz on a headphone, it doesn't make it. Above 1 kilohertz, there are some forgiving sins, because subjectively people aren't as attuned to making that perfect. And it has a lot to do with the fact that you move your head, or have any of you listened to a near field monitor and put pink noise on it? So you listen straight up, pink noise, and then you put your head forward like this. The timbral change is dramatic. And when you're like there's a straight on the head, there's a great big notch at about 7 kilohertz. But when you do this, that notch is gone. So that's how you tell height and distance. So these huge variations in frequency response, when you put something that covers the ear, is very forgiving. But below 1 kilohertz, it's not. It has to be very accurate.
Is the threshold smaller for headphones and speakers, above or below 1K?
I'm not sure, but I would suspect it might be, because once you block off the brain from hearing things on both sides, the brain doesn't know what to do, so it puts all the sound in the middle of your head. And so it's very much more forgiving at high frequencies. Because if you look at the frequency response of all the different angles on KEMAR, for example, above 3 kilohertz, it's just the dog's breakfast. It's all over the place.
That's a new one.
That's a new one for me too.
Is that a technical description?
No, that is.
I got a comment, Jude.
Yeah.
So Jude was asking what other measurements might be useful, and there was a paper presented in Denmark by I can't remember his name now,
The
but
last guy?
the guy who's got a consulting service, headphone measurement consulting service.
Oh, yeah.
And he was
Struck.
right, Chris, and he recommended some changes. One of the things that would be interesting for you guys to understand is that the IEC specification for headphones is a very weird document and has it has some very they describe 2 or 3 different ways of measuring headphones, and then they say the results from these 2 or 3 different methods will be different, and so there's no right one. But Chris recommended a couple things. One, he recommended multi-tone distortion measurements as much more telling than regular distortion measurements, single-tone distortion measurements. He suggested that sensitivity be done in I don't think he used SPL. I think he used a different.
Pascal?
Yeah, I think it was Pascals per volt, rather than using the power measurement, because if you do dB per watt, then you have to know what the impedance of the driver is in order to kind of match apples to apples. And then another thing that I like is a lot of the enthusiasts are on their home rigs are doing waterfall plots for which I like the idea of, and I wish I did them myself, but I don't. So I think there's some other measurements that are useful that we're not seeing. And then to make one comment, Gunther Thiel had a paper at the conference but didn't present it, wasn't there to present it. But in it, he recommends a diffuse field response headphone in future for professionals, because it's the most linear coupler to the, has the most linear coupling to the ear, and then to do any room equalization or binaural room impulse response stuff or virtualization stuff electronically prior to the headphone. So his recommendation is headphones in future should have diffuse field responses and then have all adjustments made in the electronics prior to the headphones. So don't know about that exactly.
Did you ever
I
try-
thought diffuse field sounds bad, but
Let me tell you something. But so the problem is about, of course, I partially agree with this idea of the diffuse field response is going to be the next target. But no one does listen to this diffuse field in music.
yeah, doesn't sound good.
Yeah.
It's not enough bass.
Therefore,
That was, I have to say, that was another thing that so many engineers said at the conference at different times about different things. Is that, well, we need more bass, you know, and it was said in like 3 or 4 different times in 3 or 4 different ways. And they were like all surprised how much bass they need.
right.
Yeah, but Sean's, I mean,
That's
you've been
true.
doing,
Well, that's the
yeah,
room
the
field.
room
Yeah.
field. That's your
Yeah.
trade name
Yeah.
for, room
Yeah.
name.
Yeah.
And then that's what Naotaka, because even your latest
Yeah,
flagship
so
headphone-
I completely agree with yours about Paul's idea.
Yeah.
Should be as a room.
Yep.
You mentioned the waterfall plots, and actually I had a conversation with Chris Struck about waterfall plots.
Yeah.
He had some interesting opinions on it. I mean, maybe not as, that were kind of like yes and no. So I want to ask these guys, what do you think the value is of waterfall plots, cumulative spectral decay plots, in headphone measurements as far
Yes,
as being
it-
telling
it-
of anything?
But I was telling you my truth. So we do not do the waterfall plotting so many, actually, because the waterfall plotting is good for the loudspeakers because they have a very bad group delay. But fortunately, headphone has a better group delay at all the time. Therefore, for the production, the manufacturing, the designing, manufacturing, the production, we do not care the waterfall plot so much. But maybe it's a good idea someday. Someday.
Well,
May I jump in?
sometimes you can see things you can't see on a normal frequency response as it decays.
Right.
And that can tell you a few things about maybe some resonances that you
Yeah.
don't want to deal with.
Right.
So, but if you're good at it, you can actually see that in the frequency response. If you're experienced.
You can see it in the impulse response too.
Yeah, you can see it in those, but sometimes it's harder to see unless you do a waterfall.
Yeah.
Yeah.
Well, they're all really just views of the same data.
Yeah, just looking at it in a different
Yeah,
way.
we used to use waterfalls a lot, but as our drivers evolved, we found that there was so little ringing in it that it actually just provided no information. And we go in and we check once in a while just to make sure we haven't done anything with it, but it turns out to be something where once you get rid of the core issues that cause ringing,
Right.
in your design, you're done.
What about you, Shankar?
I mean, like Dan said, we use it once in a while, but most of the time it's very hard to evaluate, with ear pads and changing in ear pads and stuff. So we use it, but it's not it's not in production every day.
How about multi-tone distortion across the manufacturers?
Yeah, I want to know if they're using that.
Yeah, sometimes we do.
Yeah.
Sometimes we do.
We do measure it as well.
Yeah, I
we
think
haven't tried that yet.
intermodulation is probably something that is much more audible and much less forgiving than things like even harmonic distortion.
Right.
Harmonic distortion, to a degree, is quite forgiving. You can tolerate, certainly at low frequencies, quite a bit of it. some people actually like it.
Right.
But didn't Sean do a paper that actually said that intermodulation distortion, as far as his findings, was one of the least, like one of the ones that didn't have a correlation? One of his
I don't
papers said
recall
that.
that.
I do recall. He
Well,
said
it
that
depends on the signal source. If you put a pure tone into a headphone, you can often, a couple of tones into a headphone, you can hear all kinds of spurious sounds. It's hard to tell with musical content because music is not steady state. And hearing intermodulation distortion in a dynamic domain is very difficult to hear. It's just the way our brain works.
Yeah, I'll have to find that.
And to me, there is a lot of discussion with the time domain response. But to me, the most important thing is going to be waveform reproducibility. And because that's the reason why we are pursuing the high resolution audio these days. And then, probably, as Sankar mentioned a little bit about this phase response a little bit, but phase has a strong correlation with this, how to preserve this original waveform of this music signals. And that's the reason why we are expanding the frequency range higher than the audible area. So there is many arguments that the high frequency measurement higher than the human audible area. It doesn't make sense. But probably some of you are read the recent ES paper, which is talking about the human being can perceive the high resolution audio or not. But most of that conclusion is some people know. Some people, this is true that some people differentiate the high resolution audio. Then also other conclusion is from this is pulled from this other. The paper is human audible. The human being can perceive very low time difference down to 5 microseconds. And because this is a very simple kind of math, 5 microseconds is equal to 200 kilohertz. Therefore, probably to keep this consistency of the waveform reproducibility, we need to think about 200 kilohertz.
Yeah, but that timing is the interaural timing.
Well, not for the monaural. Monaural.
All right, so the time is getting more limited. You want to say something, Jay?
I just actually, it was a slightly different aside there, but one of the things that I think is really interesting is if you look at the core measurements that we typically use, almost all of those were designed around World War II. Frequency response, step response, impulse response, phase, all these things were done when they were trying to make better radios for the Army. And we haven't, other than putting in some DSP functions like being able to generate waterfall plots and stuff, that we haven't really moved past the notion of kind of static measurements. And music, of course, is an utterly dynamic experience. And if you look at what the acoustics people have done who do room acoustics, concert venues and stuff, they have metrics for things like clarity, and how articulate vocals are, et cetera. And nothing like that has really been done in our space.
Well, that's where I wanted to go to,
Yeah.
because I was talking to Jacob, who's now at Head Acoustics. That's the head that you use. And they have scores for things like voice quality, like a score, right? And so it would be lovely if we could arrive at something like, audio quality score, right? That's sort of an amalgam of, like all the different measurements. But the question is, what do we need to measure here?
Exactly.
Right? And it's because the whole idea is to come up with a measurement, at least from my standpoint, because we have a consumer-facing site, you have a consumer-facing site, what measurements can we show that are telling to somebody when they can look at it and say, I can actually suss something out, independent of being able to listen to it, which a lot of people can't, because right now that story just isn't, in my opinion, necessarily always told in measurements. So, what are some of the measurements that we can do? I mean, I have an analyzer now that's well beyond my capabilities, but I know in talking with Audio Precision and some of my friends there, there may be some interesting things we can explore there. But anyways, I want to know if you guys have any idea. Because remember, we have a different, you're doing it behind the scenes. I'm doing it, he's been doing it. Oh, go ahead, Shankar.
So years ago, before we started making headphones, we were making speakers and for the military. and one of the things that was used was something called the intelligibility test, because this was trying to figure out how clear they can hear.
Right.
So there is a standard that actually says, okay, these are some words, and these are pronounced by, actually you can even get the MP3, I believe, or you can say these words and see how it's easy to perceive on the other side. So we have done the test long time ago, but that was one of those tests like what Dan was mentioning, where you can, is it easy to say something, okay, this is 99% intelligibility.
Right.
But how do you do that for music is a different matter.
Yeah, that is very
Yeah,
different.
and you know, we in a sense, we don't even know what questions we want to agree on yet about what we want to measure. Like, for example, if I say I want to design a headphone that sounds natural, I will have almost certainly a completely different take on what the priorities are for the different things that express natural than anyone else at the table will be. And so, for the industry to coalesce around some form of a standard that could convey something like sound, accurate sound stage. It's, well, what is, how do we pull that together? Because we're going to perceive very different things about that. Is that accurate sound stage means that, a vocalist front and center is right, I'm in row 1, but the decay in the halls goes off to infinity, or should the vocals be 7 rows back? What does that mean? And so there's like a whole perceptual discussion to have to be able to organize the thoughts around what measurements actually would reflect reality beyond just technical, impulse response and time and frequency domain stuff.
Well, I know one thing is that, with normal headphones, it's really hard to really predict anything like these things. Of course, you mentioned earlier about some deviations in the frequency response to create some kind of artificial sound stage.
Yeah.
And that correlates with how we hear, because at different angles of, like, as we move up, our frequency response at high frequencies around that region gets better. So when we hear higher frequencies, we tend to think it's elevated. And so you can play some games like that. But in terms of spatialization, other than just some frequency response things, it's very difficult, because it's all to do with the timing between the two ears. And maybe we should do a measurement that kind of does comparisons between left and right channel, but then it's all very much dependent on the source material and the signal that you put into it. I mean, when you listen to binaural recordings, the sound is outside your head. And it's because it's got the right information going into both ears. With a normal recording that was recorded with near-field microphones or spaced omnis in a concert hall, you don't have that information to take the sound outside your head.
I want to add, because it's an interesting point where you were talking about scores for intelligibility and things like that. I know for sure that Sennheiser, in their DJ headphones, has a curve that has a target curve that is specifically for that activity as a professional DJ, and it is not flat, and it doesn't sound good for music the way that I would like to listen to it. But evidently, Sennheiser believes that it's much better for a DJ to work in that environment. Similarly, if you want a headphone that has good speech intelligibility, then you may, you want it to emphasize and those kinds of sounds. So when you answer the phone, you want to be able to hear it clearly. But that wouldn't necessarily be appropriate for music. So it's interesting that as headphones become more multi-purpose, so you're wearing now a noise-canceling wireless headphone, you answer the phone on it, you listen to movies on it, you listen to music on it. It may be that that in the end they'll want to change the profile, each time they change what the source is. But it makes it very, very challenging to go, what's the right tuning? Well, what are you listening for? What are you listening to?
Yeah. So in this hour, I think we've not answered the question about subjective impressions and measurement. So, but here's what I would like to do. Here's what I'd like to do. So you and I get a lot of headphones across our desk. At my office, Sony's been there many times. I remember the first thing you said when you walked in was, wow, right? We have a lot of headphones. And it looks like the 4th floor of Yodobashi Akiba blew up in there. And, but we get a lot of headphones. And one of the things I want to do is use the analyzer to capture as much data as we can. Like right now, what's happening is they they take blood samples from Tour de France riders, right? And then they can test them years down the road, you know, when as they find substances and things like that. And I want to capture as much information in the measurements as we can, and then as we start getting more and more headphones measured, I know you've been trying to do this, but I want to do this. I mean, but I want to look at a whole bunch of different, you know, measurements and plots, and then eventually try to see what in common some of the headphones we have, and some of it we can tie to subjective impressions right on the forums, right? Because now, but you have to try to suss out hype from, you know, like long-term impressions. I think we can make an assumption about what people in the long run are saying about an LCD2 or Sony MDR V6, or you know, because they've been around for so long, or your headphones or yours, right? Over time, we have a subjective impression, I think, that, you know, of a headphone that we, you know what I mean? Like once like the hype dies down and everything, we can kind of start to see these are characteristics that we almost universally agree on, you know what I mean, with a headphone?
Yeah.
And then start like looking at that relative to all this data we capture.
I think you'll find, as I said earlier, that there'd be a strong correlation below 1 kilohertz. A strong correlation.
I guess we gotta go to Q&A because we're out of time, so. Go
I
ahead,
have a
Evan.
question. This is something that's always struck me in reviews and things like that with headphones, is some headphones like come into their own or sound better to me at higher volumes. So like they sound flat, low, at where I want to listen all day, right? And so I know they measure a 90 dB per watt, and I don't know how that correlates or the ear, how personal it is. Are we even measuring at the right level? Like should we be measuring where people are actually listening?
Well, they are.
Equal loudness stuff.
Yeah, that's one of the key questions is what did the designer listen at when they were voicing it? You know, because most of us probably do not listen at ear-splitting volumes when we design headphones because by now we'd be deaf. So, you know, like most of our headphones, the tonal balance is optimized around 85 to 95 dB because that is what allows safe long-term listening. You know, in 95 I'm talking peaks, not like high-power average or highly compressed music. And if you play that at a lower volume, you know, just based on human perceptual response for low and high frequencies, it's going to sound different. You know, and if you turn it up even higher, it will still sound different. So, but you know, sometimes matching the level that you listen at to what the designer's doing makes a big difference.
So should like that, you know, watts or something, you know, that's a question.
Yeah, that could be a metric. It could be a metric you.
Hating it, liking it, one guy listens louder.
It could be a metric you put in the specification, and that's a very good point. Because of the Fletcher-Munson curves at low frequencies, that's why in the old days, you had a loudness button on the front of your receiver. So that if you listen to the music at a lower volume than they actually recorded it at and made their sonic judgments at that level, and you listen to it at a lower level, you're not going to get the spectrum balance that they heard when they were listening to it at a higher level. And that's a bit of a challenge because we don't know how loud you guys want to listen to the stuff. So it's a bit of a shot in the dark.
With the super headphones, and you're like, okay.
Yeah.
Right.
And it's almost always Michael Jackson's Thriller that it's at that volume. I don't know why.
Yeah.
So, but it is easy to identify Sony headphones. And so if there is a label with professional, yeah, it's these are pairs as intended to listen to the slightly higher level.
But no, that does have a big impact on what something sounds like. Yeah. Oh, go ahead.
I think it's a good idea that you guys might consider just taking a whole bunch of measurements and then analyzing headphones based on the subjective impressions and trying to correlate things. Because I got my headphones measured at Audio Precision upstairs, and it was interesting to see how many different tests they have, and I don't even know what half of them are. So it's kind of interesting.
Oh, yeah, there's a lot of information to be
Like
sussed out.
energy time curve was one of them, and he was explaining it as like an impulse response summed up over time. So it's mind-blowing me. Like, I've never seen this before.
Time for Tyll to write a new article.
Yeah.
I like that big data approach, Jude. I think that would be really interesting. Because, I mean, once you have that visibility, you know, questions will come up that you haven't even thought about.
Yeah, because I think some of the more interesting data is the subjective impressions, right? I
Yeah.
mean, because
Well,
again,
that's-
over time,
That's what counts.
yeah, I think we can probably make a safe call on a Sennheiser HD800 on the subjective impressions of an HD800
Oh, yeah,
over
sure.
time. And so
600s?
600, same thing. And there you go. And so maybe that's the approach, right? Is to tie in but it might not be because the frequency response alone doesn't explain the 800 800S difference, right? In the bass range. the frequency response alone does not.
But here's the question:
Yeah.
if you had a large, if you are able to correlate large numbers of people with large numbers of data, does it make it any more meaningful for the individual?
Yeah, that's true.
Say,
Well, no,
you're
but-
still stuck with a similar problem.
No, but what if you can then at least characterize the sound, even if it's not preference?
Yeah.
Right? I mean, because what I'm trying to say is we can subjectively, I think we can make a call on the 800
Yeah.
and what it sounds like, whether you like it or not,
Yeah.
right? Because that's the point, is over time it settles out. I don't like it because, or I like it because.
I would tend to think that that you can do that from the measurements as they exist in terms of a ballpark.
So,
I don't know.
So-
Sometimes, yeah.
so the HD 800 and 800S are both good headphones. So the difference is, minimal. Finding a correlation between these things might be hard, but from a really bad headphone to a good headphone, probably yes.
Yeah.
Yeah. So when you have good headphones, there might be small differences between them, but it's going to be very hard to find the nuanced. Even the reviews will be all over the place on those things.
Yeah.
So and reviews over a period of time actually change. You
Yeah.
just need to read Tyll's reviews of the same, headphones after 3 months or 6 months, and you will see that his impressions on newer headphones have changed than older headphones.
Right. That's true.
Oh yeah.
That's true.
There's certainly true that current experience informs the past impressions, and the impression of a headphone does change over time.
Yeah. Revisiting
Because the
reviews.
context
Yes.
changes.
Oh, I know. I already know the reviews I posted out if I revisit it, like, just because of the way the market's changed over time.
Agree with that?
I wish we had time to discuss, do measurements inform a review? Because I think they do sometimes, too much.
If I want to be biased by anything, it's by the measurements.
I don't. I want to listen and make the call. Yeah.
I think I can fool myself too easily.
Well,
That's actually a specific, I take the exact opposite approach. It's like, I do not measure until I've listened and come to my core conclusions.
Yeah, well, that's what I appreciate when we
Yeah.
talk, and then when I
It's
talk with
funny.
Now comes to my office, you've been there several times, and you'll
Yes.
bring a headphone, a prototype, and we'll listen to it, and they seem most moved by what this collection, you go to the studios, you go to different,
Right.
and he's most moved by what people are saying about the sound of the headphone, and I know that's
Yes,
for all of you.
actually,
Yeah.
we rate this measurement at the early stage of the
yeah.
development. We do many measurement to give it a higher efficiency for the time to quality value. But so at the end of from this middle of this design process, the time for the measurement is less than 20% of our whole time, and most of the time is spent dedicated for listening, because the people who purchase our headphones doesn't measure normally,
Right.
except you.
Except and time. But all right, guys. Well, we're out of time. Thank you so much for participating, and thanks for.
you, guys.
Yeah.
Thanks, Jude.
Thank you, Tom.